In March 1987, Chadian forces overran the Libyan airbase at Ouadi Doum in northern Chad. During the rapid retreat from Ouadi Doum, Libyan forces abandoned an export version of the Soviet Mi-24 attack helicopter, designated the Mi-25 Hind. The aircraft later became the objective of a highly classified intelligence acquisition mission known as Operation Mount Hope III. The goal was to extract the rotorcraft from the Sahara and transport it to the United States. This was not a forensic reconstruction of a shattered airframe or a survey of a crash site. The helicopter was substantially intact and potentially flyable, although a bullet had struck one engine, at an airfield now controlled by Chad near the Libyan frontier. When high-value aviation technology is left behind by retreating forces, it enters a narrow survival window. Original operators may strike their own abandoned hardware to prevent capture and reverse engineering. After Ouadi Doum fell, Libyan aircraft repeatedly attacked the airfield in an effort to destroy equipment left behind. The substantially intact Mi-25 therefore remained vulnerable, while its armored construction and Soviet design made it a rare intelligence opportunity. Extracting the aircraft required navigating a rigid legal and geopolitical boundary. The abandoned airfield was located entirely within the sovereign borders of Chad. The United States military could not cross the border and remove the machine without triggering a severe international incident. 14 months after the initial abandonment, diplomatic negotiations finalized the access parameters for a June 1988 operation. The Chadian government granted explicit permission for the retrieval. In exchange for territorial access, the United States reached a negotiated settlement with Chad, although the official operational history does not publish its value or exact terms. The American force remained responsible for the specialized extraction logistics. United States personnel reached Ouadi Doum in advance, prepared and rigged the Hind, and arranged the fuel and transport required for a recovery that could not depend on a fully equipped local support network. The threat environment above the desert remained strictly active. The extraction team would be operating on the ground at a known, fixed coordinate while rigging a heavy aircraft for flight. Because the planners feared Libyan interference, French forces supported the operation, but the exact form and duration of fighter coverage remain unconfirmed in the available official account. The mission, therefore, cannot be described as operating beneath a documented, continuous fighter screen with a precisely defined intercept mandate. The recovery plan relied on moving the massive Mi-25 Hind entirely by air. Ground transport had already proved operationally unsuitable. An earlier recovery attempt cut another Hind apart for movement by truck and failed to preserve a working aircraft. The operation demanded heavy-lift rotary wing assets, which meant deploying the MH-47D Chinook helicopter. The two Chinooks, more than 60 crew and maintenance personnel, and their support equipment crossed the Atlantic to N'Djamena aboard a single United States Air Force C-5A Galaxy. The capital airport provided a secure staging ground, but it was located at the extreme southern edge of the operational theater. From the secure staging base in N'Djamena, the mission now turned to range. The target airfield lay exactly 550 miles from the secure staging base at N'Djamena, far beyond the unrefueled reach of the two MH-47D Chinooks, assigned from Company E of the United States Army 160th Special Operations Aviation Group, later incorporated into the regiment known as the 160th SOAR. The aircraft had no air-to-air refueling capability. Before the crews could address the aerodynamics of lifting the Hind, they had to extend the Chinook's range without sacrificing the power margin required at the objective. To bridge this deep desert gap, the engineering team had to completely reconfigure the internal geometry of the Chinooks. The decision was made to install a temporary auxiliary fuel system directly inside the cargo cabins of both helicopters. Additional fuel tanks were rolled into the cargo cabins through the rear ramps and connected to one another. This temporary internal system was then filled for the outbound flight. The internal tanks carried 600 gallons of additional aviation fuel, giving the helicopters the range needed to reach Ouadi Doum without an outbound refueling stop. Adding this temporary liquid volume fundamentally altered the operational capability of the helicopters. Integrating an internal auxiliary fuel system forces a rigid mass versus range trade-off. The additional internal fuel extends the flight radius of the machine, but it aggressively consumes the maximum gross weight limit of the aircraft. The 600 gallons of liquid volume added approximately 5,000 pounds of dead weight to the fuselage. A helicopter cannot simultaneously carry the maximum internal fuel load required for extreme range and the maximum external lifting capacity required for heavy extraction. The lifting power generated by the tandem rotor blades is finite, and every pound dedicated to internal fuel is a pound subtracted from the external cargo hook. Helicopter performance is strictly governed by gross weight and environmental conditions. In the extreme heat of the African desert, the thin air already degrades aerodynamic lift. Desert heat and thin air further degraded aerodynamic lift, leaving the heavily fueled Chinooks with extremely tight margins. This unyielding physical constraint dictated the exact flight profile of the ingress phase. The Chinooks had to depart the staging base heavily laden with the auxiliary fuel, flying dangerously close to their maximum allowable weight limit. They could not lift any external cargo during this outbound phase of the mission. The transit flight across the featureless terrain became a deliberate, calculated process of burning off mass. For every hour the helicopters flew north toward the objective, the turbine engines consumed the internal liquid weight, slowly shifting the power margin of the aircraft. The crews had to fly a direct flight path, unable to deviate or loiter because every drop of fuel was factored into the weight calculation. By the time the Chinooks approached Ouadi Doum, the internal blivets were nearly empty by design. The 5,000 pounds consumed in transit had restored the external lifting margin required at the target. The extraction crews landed beside the Hind with the required power margin restored. They could now hoist the Soviet attack helicopter, but attaching it to an external hook introduced a severe aerodynamic penalty. The decision to extract the target aircraft via a 550-mile air route required an entirely new logistical architecture for the return flight. Carrying the Hind as an external load required careful performance planning, although the final rigging proved exceptionally stable at speeds reported up to 110 knots. A direct, non-stop flight back to the staging base was operationally impossible. The extraction planners had to construct a staggered egress path, selecting specific remote coordinates in the desert to support the returning aircraft. This operational method relies on establishing forward arming and refueling points. A bounding flight path requires temporary, remote staging areas where transport aircraft land ahead of the returning helicopters to provide aviation fuel and rigging support. Instead of flying a continuous route, the lift helicopters execute a leapfrog pattern. They fly a measured segment of the journey, land at a pre-positioned refueling node, take on fuel, and then proceed to the next node. For this specific extraction, the egress route was mathematically divided, using two distinct desert outposts. The first refueling node was established at the remote settlement of Faya-Largeau, and the second was positioned further south at Moussoro. Faya-Largeau supported a temporary Air Force refueling point, while Moussoro was an active airfield garrisoned by the French Foreign Legion. To make these geographical points functional, United States Air Force C-130 Hercules transport planes were integrated directly into the egress plan. The four-engine C-130 transports functioned as mobile logistics hubs, and each refueling point had to be operational before the Chinooks arrived. At Faya-Largeau, that vulnerability became immediate. At Faya-Largeau, a waiting United States Air Force C-130 had established the first refueling point. The aircraft was already on the ground before the Chinooks arrived, but its fuel system failed and had to be repaired before the transfer could begin. Fuel transfer itself can generate static electricity, and low humidity can increase the probability of a discharge, making bonding and grounding important controls. Once both helicopters were refueled and the Hind was reattached, the formation departed for Moussoro. The second stop was not another leapfrog by the same transport aircraft. Moussoro was an airfield manned by the French Foreign Legion, whose personnel passed refueling hoses through the fence to the Chinooks outside the compound. Beyond Moussoro, the remaining question was whether the suspended gunship could survive the turbulent flight between refueling points. Suspending the deactivated Mi-25 beneath another helicopter created a severe aerodynamic problem. Its large fuselage and vertical tail could catch the relative wind, allowing yaw or oscillation to develop if the center of gravity or rigging was wrong. A violent broadside rotation was not inevitable, but excessive movement could still threaten control, the sling system, and the lifting aircraft. The Hind, therefore, had to be prepared and balanced for stable forward flight. To meet the tandem rotor lifting limits and reduce instability, the ground crew carried out a rapid, controlled teardown of the Hind on the desert tarmac. The rotor blades were removed, and other unnecessary external items were stripped away where required, although the available mission account does not identify every component. The disassembly reduced dead weight and aerodynamic cross-section, improving both power margin and load stability. With the hazardous lifting surfaces removed, the loadmasters focused on the physical handling geometry. Rigging a structurally intact fuselage requires precise load distribution. The team rigged the Hind to the dual external cargo hooks beneath the MH-47D, distributing the load between the forward and aft hooks. The exact sling material and fuselage attachment points remain unconfirmed. The lengths of these forward and aft suspension cables had to be mathematically matched to the center of gravity of the stripped target. The rigging geometry was deliberately calculated to force the suspended machine into a slight nose-down attitude. Forcing the nose down ensures that the relative wind hits the narrowest cross-section of the fuselage first, pinning the tail stabilizer straight back and preventing the massive frame from violently rotating sideways into the slipstream. Executing this lift required precise synchronization between the ground rigging team and the flight crew hovering directly above. As the lift helicopter slowly increased power, the heavy slings lifted off the desert floor and pulled taut. The flight engineers lying on the floor of the lifting aircraft monitored the cable tension through open floor hatches, calling out altitude and drift corrections to the pilots. The hovering aircraft had to be positioned precisely over the geometric center of the target, lifting straight up to prevent the load from dragging laterally across the tarmac. Once the dead weight broke contact with the earth, the pilots executed a slow, vertical hover check. They monitored engine torque and vibration, verifying that the rigging geometry held the load stable. With the center of gravity confirmed and the external connections secure, the extraction aircraft transitioned into slow, forward flight, carefully managing the airspeed to prevent the wind from overpowering the rigged load. The aerodynamic load is stabilized, starting a rigid countdown against operational exposure. According to a post-mission brief, the crews dismantled the two Chinooks twice, rebuilt them once, and completed the mission in 67 hours. The figure reflects the extraordinary aircraft turnaround and execution tempo, not a separately documented hard limit running from arrival in Africa to final departure. Every mechanical action still mattered, because delay increased exposure and threatened the schedule. Approaching the remote staging areas established along the egress path, the flight crews faced a mandatory, time-consuming mechanical transition. A heavy-lift helicopter carrying an external combat aircraft cannot simply land on a runway to take on fuel. The physical mass of the suspended payload physically blocks the landing gear of the lifting platform from touching the ground. Therefore, at each pre-designated remote node, the continuous forward flight had to halt, forcing the crews to execute a precise unhooking procedure. At each refueling stop, the Chinook lowered the Hind to the ground and released the load. The helicopter then moved clear, landed, and interfaced with the waiting fuel crews before returning for the next hookup. The maneuver demanded controlled placement, but the exact hover height, aircraft attitude, and release sequence are not confirmed. Each stop was therefore a complete reset of the lifting system, rather than a simple halt. While the flight crews managed the transfer of aviation fuel, the ground rigging teams had to navigate the hot dust to gather the heavy slings, untangle the thick hardware, and manually prepare the target aircraft for the next lift sequence. Working in the extreme African heat, managing thick synthetic straps and heavy metal rings drained the physical stamina of the specialized crews. Each minute spent managing the hardware on the ground added delay, exposure, and strain to the mission. When refueling was complete, the Chinook maneuvered back over the resting Hind. Trained personnel reconnected the sling load under crew direction, and the flight engineers confirmed the hooks before the next lift. The slack was slowly pulled tight, the geometry was checked, and the massive payload was hoisted back into the slipstream. The formation then continued south toward the capital. With exactly 45 minutes of flight time remaining to the secure runway at N'Djamena, the formation encountered a massive, unforecasted sandstorm. Airborne particulate density creates a rigid meteorological obscuration limit for rotary wing flight. The dense, suspended sand acts as a zero-visibility floor, completely blinding optical sensors and removing the visual horizon required to keep the aircraft oriented in space. When an aircraft encounters a solid wall of obscured air, the flight crews are forced into a strict decision matrix. They must either abort the flight and land immediately, initiate a steep climb to break out above the weather system, or aggressively drop altitude to stay underneath the obscuration and maintain continuous visual contact with the terrain. For this specific extraction flight, two of those three options were mechanically impossible. The vertical dust wall extended approximately 3,000 feet into the atmosphere. The heavy-lift Chinooks were heavily burdened by the external payload suspended directly beneath their airframes. This mass, combined with the severe aerodynamic drag generated by the sling load asymmetry, meant the helicopters simply did not possess the excess engine power required to initiate a steep climb over a 3,000-foot weather system. They were strictly locked into a low-altitude flight profile. Aborting the flight and attempting an emergency landing blindly in the deep sand was equally hazardous. Setting the external load down without a clear visual reference could damage the Hind, the rigging, or the Chinook, making an immediate landing a hazardous choice. The Air Mission Commander ordered both Chinooks to reduce speed and separate by 1 mile as the sandstorm overtook them. With the formation spread out, the crews prepared to lose visual contact inside the wall of dust. No confirmed account places the aircraft only a few feet above the desert floor. Inside the sandstorm, the two crews lost visual and radio contact and continued separately through the obscuration. The flight engineers monitored the swinging payload, ensuring the turbulent crosswinds did not force the dead airframe into an unrecoverable pendulum oscillation. The isolated crews continued toward the capital until the thick wall of suspended sand began to dissipate. The lead aircraft broke out of the heaviest dust with the N'Djamena airfield about 12 miles away. Unable to see the second Chinook, the lead crew raced to N'Djamena, lowered the Hind onto the designated drop zone, released the suspension cables, and landed before the storm overtook them again. Only afterward did the second Chinook emerge and make its own landing, completing the transit phase. The logistics teams immediately initiated the final loadout sequence. The recovered Hind departed first aboard one C-5A Galaxy, while the two MH-47Ds and their crews were dismantled and loaded later aboard a separate C-5A. The remaining task force departed afterward, completing the recovery and beginning the difficult journey back to Fort Campbell.